Okay, so the next question that we have here is question number 4, and it says that the following is the record of goals scored by Team A in a football session. I don't exactly know what a football session means, but well, I have actually solved this problem once. It's not that hard to understand the context. So the record of goals scored by Team A in a football session, that's basically this information here. So you have the number of goals scored, and and you have the number of matches, and the number of goals scored 0, 1, 2, 3, and 4, and 19753. So you can think of this as, for example, these as your x sub i's and these as your f of i's. And so when you do so, you will get basically this was related to Team A. These were the goals scored, and these were the number of matches in which basically those number of goals were scored. Now there was another team B. Now about this Team B, the mean number of goals scored per match, the mean number of goals scored per match was 2. That was 2, and the standard deviation with a standard deviation 1.25 goals. Standard deviation 1.25 goals. And as you can see over here, basically the unit over here is goals. So that is 1 goal, 2 goals, 3 goals, 4 goals, and so on and so forth. So, and you can see that the unit for standard deviation becomes basically again goals, meaning that, for example, if you have some data, for example, you have 0 goals, 1 goals, 2 goals, 3 goals, 4 goals. If you take the mean of this data, you'll get, for example, x bar is equal to, for example, let's say, for example, 2 goals. And the unit becomes again goals, because you take all of basically 0 goals, 1 goals, 2 goals, and so on and so forth, meaning that the formula for x bar is equal to sigma f of I x of I divided by sigma f of I, for example. So this would be some constant number, the number of all of the frequencies added together, and this would be basically you take each x of I multiplied by the frequency. So over here the unit is goal, and multiply this by some constant, and that the unit still remains goal. And then you have basically then x1 plus x2 plus x3 plus all the way up to, for example, x of n, and of course there is some f of I, there is some, for example, there is all of these f of i's, basically f of 1, for example, f of 2, f of 3, and so on and so forth, multiplied by these as well. So you're adding basically over here, the unit is gold. The unit over here is gold plus gold plus gold. So gold plus gold plus gold plus gold, it will give you gold. So the unit remains gold. And the unit remain anything you might have started with from the very beginning. For example, if the unit was, I don't know, kilogram from the very beginning, when you take the mean of all of those observations, the unit still remains kilogram. Now, when you have, for example, when you have all of these observations, for example, where let's say the unit is kilogram. For example, you have 100 observations where all of the observations are in kilogram. Now, when you take the variance of those observations, variance is sigma squared, and it's equal to 1 over n times sigma of f of I times x of I minus x bar whole squared as I goes from 1 to n. So you see over here, you take your unit and raise it to the second power. And so the unit of variance over here would be kilogram squared. But then standard deviation is nothing but basically the square root of sigma squared, the square root of variance, which would be, for example, in this case basically the square root of kilogram squared, which is going to give you a kilogram again. So the unit remains the same in standard deviation. So you need to be careful about, not careful, but well, you need to understand these things about these measures so that you can basically use them properly, in not in a situation where, and basically not use it in a situation where you're not supposed to use it. Now, so over here for team B, we said that the mean number of goals scored per match was 2, and with the standard deviation 1.25 goals, and this is again the unit here. Okay, so that's basically a little bit to understand the measures that we have used so far. Now, one more thing that we need to do here is okay, so let me see. Okay, so now the question that we want to answer here is find which team may be considered more consistent. So which team can be considered more consistent? So more consistent means less variable, of course. Less variable, meaning that the coefficient of variation CV that we talked about before, which is equal to basically sigma divided by x bar times 100. Basically, in whichever case this value is lower, that case it can be considered more consistent or less variable. In whichever case this measure is basically higher, then that case can be considered more variable. or less consistent, of course. So now in order to do that, of course, as you can see, I need my X bar, I need my sigma. So I have my X bar here, the mean number of goals scored per match. I can take it as X bar. And the standard deviation 1.25 is already over here. So I can use both of these for team B. So for team B, I don't have to calculate anything. Now for team A, I need to calculate X bar and sigma. So in order to do that, I can form a table here for team A. For team A, I can form a table here and write all of these numbers here as for example 0, 1, 2, 3, 4 as my X of i's, and basically these are my F of i's, so I write them as 1, 9, 7, 5, and 3. Now to calculate X of I and X bar and sigma here. So you can calculate, for example, X bar as sigma X of F of I times X of I over sigma F of I. And that you can calculate, for example, sigma F of I X of I would be F of I times X of I. And that would be, for example, 0, 9, 14, 15, and 12. And so sigma F of I X of I is equal to, for example, 9 plus 14 plus 15 plus 12, which is basically 27, 37, 37 plus 4 is equal to 41, and 50. And your sigma F of I, is equal to 10, 17, 17 plus 13 is equal to 30. So, 9 plus 14 plus 15 plus 12 is equal to 50, and 10, 17 plus 8 equal to 25. How did I get to 30? That's 10, 17 plus 15 is equal to 25. This is supposed to be 25. 25. Now if I calculate X bar here as sigma F of I X of I, which is equal to 50 divided by 25, that gives me a 2. That means that my X bar is equal to 2. So, and you see that for team B, X bar was also equal to 2. Which means that the mean of team A and team B were the same. So I don't really need to calculate the coefficient of variation. I can just simply calculate the sigma and compare the data that way, meaning that basically, for example, if I write the coefficient of variation of 1 related to, for example, team A, that would be equal to, for example, sigma 1 divided by X of 1 bar times 100. And related to team B, I can write CV2, for example, which would be, for example, sigma 2 divided by X2 bar times 100. And you can see that in these two formulas, the hundreds are, of course, two constants multiplied by these two fractions, which are the same. X1 and X2 are the same. Both of them are X1 bar is equal to X2 bar is equal to 2. So in whichever case, basically the sigma is a larger value. In that case, the the coefficient of variation is going to be a larger value because these sigmas are in the numerator. So I can simply compare the sigmas here. So now to count the sigma over here has already been calculated as 1.25. Now the sigma over here can be calculated, and you know that sigma is equal to basically sigma squared is equal to sigma squared is equal to, let me see, I always mix these up. Okay, so sigma squared, which is basically nothing but variance, is 1 over n times sigma of f of I times x of I minus x bar all squared as I goes from 1 to n. And then of course sigma is, when you take the square root of this thing, that becomes sigma, which is standard variation. So you can start with you can start with variance, and then from variance you can calculate your sigma. So 1 over n is nothing but basically sigma f of I, that you already know. And I need to calculate x of I minus x bar, x of I minus x bar whole squared, which is in this case equal to, for example, 0 minus 2, which is negative 2. Negative 2 squared is equal to 4. 1 minus 2 is equal to negative 1. Negative 1 squared is equal to 1. 2 minus 2 is 0. 3 minus 2 is equal to 1. So 1 squared is 1. 4 minus 2, 2. 2 squared is equal to 4. And if I basically multiply f of I times x of I minus x of bar squared all I need to do is multiply this column by this column. So 1 times 4 is equal to 4. 9 times 1 is equal to 9. That's a 0, that's a 5, and that's a 12. And so sigma f of I times x of I minus x bar whole squared is equal to basically all of these numbers added together. That's 13 plus 5 is equal to 18. 18 plus 12 is equal to 18 plus 12 is equal to 30. And then your sigma squared would be basically 1 over n, which is 1 over 25. 1 over 25 times basically sigma f of I times x of I minus x bar squared, which is equal to 30 divided by 5, 5 divided by 5, 6. So that's 6/5. That is 6/5. That is your variance. Now sigma is equal to the square root of 6/5, which is equal to, if I calculate 6 divided by 5, 1 times 5 is equal to 5, 1, 0, and 2 times 5 is equal to 10. So that is the square root of 1.2. And the square root of 1.2 is, very surprisingly, a value like this is 1.01. The square root of 1.2 is 1.01. It's actually 1.1. So 1.1 times 1.1 is equal to 1.21, right? So I can write this as 1.1. You don't really expect the you don't really expect the value of the square root to be so close to the argument of the square root function, but that's actually the way it is. So you have 1.1 here, and so you can see that your sigma over here is 1.1, your sigma over here is 1.25. So that means that the question was which team can be considered more consistent. More consistent means less variable, which is team A. So team A can be considered more consistent. So question number 4, the answer is A. Now question number 5. This is something I would call a bad example, because it's unnecessary. Well, it is trouble, but it's not unnecessary trouble. There are some examples or exercises that I would call twisted exercises, meaning that it comes from a twisted mind. They twist things unnecessarily in a cunning way, in a cunning way sometimes, and it makes it impossible for you to get to the answer. And they do it with no good intentions. Sometimes some people do that. So that's something that I call twisted exercises. I never solve twisted exercises. They do exist in basically, well, I'm not going to give you the where I've seen those, but I have seen a couple of them. I never solved those kinds of exercises. There is no point in doing that. And there are basically exercises which I would call good exercises, and those good exercises, of course, you should do them. You learn a lot of things while solving those exercises. Now there is some category that I have made up, actually, and that I would call a bad exercise. But still, there is a bad exercise is something that I've made up to refer to some exercise which is trouble, meaning that you have to think a lot about different things. But now there is again, you can categorize this category, the bad exercise, you can categorize it into necessary and unnecessary. So the necessary bad is something that, of course, these are no standard categorization of anything. I've come up with these exercises with these categorizations on my own. But the necessary bad exercise is something that you do, but you still have to do it because you will learn a couple of things in the process. When something is unnecessarily bad, what that means is that, well, the exercise is bad. You have to keep thinking about different things and it wastes your time, and still you don't learn anything in the process. So now that you know about this categorization of mine, let's go and solve this problem. This problem, I would call it a necessary bad exercise. So now the question is the sum and sum of squares corresponding to length x. So we have some length x here in centimeters and weight y, and we have some weight y here in grams of 50 plant products. of 50 plant products. Of 50 plant products are given below. So these are, we have the sum and the sum of squares of this length x and this weight y. The units are in centimeter and in grams. And the question that you want to answer is, which is more varying, the length or the weight? Which is more varying, the length or the weight? Okay. Now basically for x, what I have is basically sigma x of I, as I goes from 1 to 50, is equal to 212. And sigma x of I squared as I goes from 1 to 50 is equal to 902.8. Now about y, you have sigma y of I as I goes from 1 to 50 is equal to 261, and sigma y of I squared as I goes from 1 to 50 is equal to 1457.6. So this is all the information that I have about this length and this weight. I mean that's actually a set of observations related to 50 plant products. So now we want to know which is more varying, the length or the weight. So let's find out. Okay, so now you have to make some assumptions here. And the assumptions that you need to make is that basically, so for example, when it comes to the length, which is x here, when it comes to the length, you have sigma x of I as I goes from 1 to 50 is equal to, for example, 212. Right? So what that means is that you had some x of I, and you had some x of, for example, x of 1 here, plus some x of 2, plus some x of 3, plus all the way up to x of 50, which was equal to 212. So you could, I'm not sure if my logic is right here, but that is the way that they have actually, I've seen a solution of this problem, and that's the way that they have solved this problem, and it makes sense to me that you can basically, that you can imagine that each of these x of i's over here, the frequency, you can imagine that the frequency of each of these x of i's was equal to 1, meaning that over here you can say that f of 1 is equal to 1, and f of 2 is equal to 1, and f of 3 is equal to 1, and so on and so forth, all the way to up f of 50 is equal to 1. So then if that is the case, and of course that doesn't necessarily have to be wrong or anything, the assumption, because for example, suppose that even x1 is equal to x2 happens to be equal to x2, then even in that case, for example, f of 1 is equal to 1 and f of 2 is equal to 2. So then you can conclude that here f of, for example, f of 1, you can call it, I'm sorry, this is 1. So again here you can basically conclude that the frequency of each of these observations is equal to 2, because the frequency of each observation is equal to 1 and both of them are the same values. That means that it's just like some situation like this. For example, let's say that x of 1 is equal to 1 and x of 2 is also equal to 1. Now the frequency of x of 1, which is f of 1, is of course equal to 1. The frequency of x of 2, which is f of 2, is of course equal to 1. So then the frequency of this observation, whatever you want to call it x of I, f of I becomes equal to 1 plus 1 is equal to 2. So you can basically, you can take basically basically up here we said that basically these are the lengths and weights related to 5 to 50 plants, and this 50 you can take it as sigma f of I as I goes from 1 to n, as 1 goes from 1 to 50, which is equal to n. So that assumption you have to make and you can make. There is nothing wrong with making that assumption. Sometimes, it's not mathematically exactly right, but sometimes you have some sort of intuition and you understand that something is right, but still you don't know how to express it completely logically. This is one of those situations. I know there is something wrong with that, but I know there is nothing wrong with that, but still I don't know how to express this completely logically and mathematically. But anyway, I have actually seen that the same problem has been solved in this exact way. Now pick whatever sort of logic you want to pick, but anyway, you can assume that basically this number 50 is sigma f of I as I goes from 1 to 50 is equal to n, and then based on that we can solve the problem. Now, in order to calculate for example x of bar over here related to the lengths, what I can do is that you know that x of bar. Now coming back to the assumption that we made, we said that sigma f of I is equal to 50 as I goes from 1 to 50. That means that the frequency of each of those observations had to be 1, otherwise this sum could not become 50, because you're going from 1 to 50 and the sum has become 50. That means that each of those observations is actually equal to 1. So then when it comes to calculating the x bar over here, what you would normally do is you would say sigma f of I x of I over sigma f of I, and since basically since the frequency of each of those observations is equal to 1, you can just simply write this as sigma x of I divided by sigma f of I, right? And the reason for that is, if you want to get into that, the reason for that is that, so suppose that for example you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You have these observations. The frequency of each of these observations is 1. The x bar over here would be basically sigma f of I x of I divided by sigma f of I. So that would be equal to, for example, 1 times 1 plus 2 times 1 plus 3 times 1 plus all the way up to 10 times 1 divided by sigma f of I, which is equal to 10, for example, in this case, divided by 10. So this is sigma f of I. Now, then the numerator, I can write it, since this one is common between all of these terms, I can write it as 1 times sigma, actually times basically 1 times basically 1 plus 2 plus 3 plus 4 plus all the way up to 10 divided by 10. So then I can write this as, for example, 1 times, and this is nothing but sigma x of I over sigma f of I. So that means that when the frequency of each observation, meaning that the f of I is equal to 1, no matter what the value of I, then your x bar, which is normally equal to sigma f of I x of I divided by sigma f of I, that you can write as sigma x of I divided by sigma f of I. And that is basically what we can do over here. So that means that then, I mean, that's the reason why I said this over here. So then if you have sigma x of I divided by sigma f of I, you know that sigma x of I is equal to, as I goes from 1 to 50, is 212. And sigma f of I is up here, which is equal to 50. So now 212 divided by 50 is equal to 25, and then over here you have 106. Now 106 divided by 25 is equal to 4 times 25 is equal to 100. We have 6 remainder. And 3 times 25 is 75. 2 times 25 is equal to 50. 10 remainder. 0, and 4 times 25 is equal to 100. And you have 0 remainder. So this is equal to 4.24. So your x bar related to, basically to the length. I'm talking about these x's, so these x's are referring to the length. So the x bar of the length, the mean length basically, is 4.24, and of course the unit is centimeters, but you already know the unit, so I don't write the units over here. It's 4.24. Now, what I can do is that I can go and do the same thing for basically for the weight. You want to know which one is more varying. So first I want to know if the x bars are the same or not. Then we can decide the rest of the way. So when it comes to the weight, sigma f of I, when it comes to the weight, then y bar is equal to sigma y of I, and I'm not writing f of I anymore, because we already talked about that. We said that we don't have to write it in this particular case. So I write this as sigma y of I divided by sigma f of I. Now sigma y of I over here is equal to 261. And sigma f of I is equal to 50. Now 261 divided by divided by 50 is 25, and that's 100, well, that's 130.5. That's 130.5, and 130.5 divided by 25 is basically equal to 5 times 5 is equal to 125. 5 times 5 is equal to 25, 2, 10, 12, 125. We get 10 remainder, 5 here, 4 times 25 is equal to 100, 5 remainder, 0, and 2 times 25 is equal to 50. So that's equal to 5.42. That is your y of bar. So your x of bar and y of bar, meaning that the mean of the two distributions are not the same. So we need to calculate the coefficient of variation, which is CV is equal to basically sigma times 100 divided by x bar, or in this case you could say y bar, for example. Now let's do this first for the length, and then we will do it for the, meaning that first we need to of course calculate the standard deviation for the length, and then the standard deviation for the weight, and then we can then calculate the coefficient of variation for the two, and then we can compare which one is more variable. Okay, so I think we came up to the point where we understood that y bar was not equal to x bar. So y bar was equal to 5.42, and x bar was equal to something like x bar was equal to 4.24. Now what we need to do is calculate basically sigma for x and sigma for y, and then compare, and then basically calculate the coefficient of variation for the two. Now in order to do that, what I need to do is I need to calculate, for example, sigma squared, which is variance, and that is equal to 1 over n times sigma of f of I times x of I minus x bar whole squared as I goes from 1 to n. And so for this particular instance, or for this particular example, I can write sigma squared is equal to 1 over n sigma of f of I. I don't have to write it as we discussed before, and x of I minus x bar whole squared as I goes from, for example, 1 to 50 in both cases. So now for basically for x or for the length, what I can write is, of course I know that 1 over n is going to be equal to sigma f of I, which is equal to 50. So sigma squared is equal to 1 over 50 times sigma of basically x of I minus x bar. In the case of x bar, we had 4.24, and I want to square this. And as I goes from 1 to 50. Now I can write this as sigma squared is equal to 1 over 50 sigma of basically can raise this to the second power, meaning that a minus b raised to the second power, which is a squared plus b squared minus 2ab. So I can write this as x of I squared plus 4.24 squared minus, basically they have negative 2 times 4.24 times x of I, which is negative 8.48 x of I. 8.48 times x of I. And so now I can basically separate these terms here. So sigma squared would be equal to, and of course this is raised to this, not raised to the second power anymore, because I already have expanded it. So x of I, sigma, I can write this as 1 over 50. Sigma of, and 1 over 50 is multiplied by the whole thing. Sigma of x of I squared as, and this is I goes from 1 to 50. So this is as I goes from 1 to 50 plus sigma of 4.24 squared as I goes from 1 to 50 minus basically sigma of 8.48 times x of I as I goes from 1 to 50. Now I know that sigma of x of I squared as I goes from 1 to 50 is 902.8. This is, so I write this as 1 over 50 times 902.8, and of course you know that sigma of 4.24 squared as I goes from 1 to 50 is just 4.24 squared. It doesn't depend on I. There is nothing here to be summed or anything. So you can write this as 4.24 squared, and this term over here you can write it as 8.48 times sigma of x of I as I goes from 1 to 50. And you know that sigma of x of I as I goes from 1 to 50 is equal to 212. So instead of this I can simply write 212. I can write 212. So what that means is that now I have 4.24 squared, which is equal to 424 times 424 and 4 decimal places. So I have 4 times 4 is equal to 16, 1, 8, 9, 16, 0. 2 times 4 is equal to 8, 2 times 2 is equal to 4, 2 times 4 is equal to 8, 0, 0, and then 4 times 4 is equal to 16, 1. 4 times 2 is equal to 8, 9, and 4 times 4 is equal to 16. So I have a 6 over here, 17, 1. 7 plus 10 is equal to 17, 1. And over here you have 10 plus 9 is equal to 19, 1. That's a 7 and that's a 1. 4 decimal places, you get 17.9776. And if I add to that 902.8 from here, 902.8, what I will get is basically 6, the 7, the 7, 17, 1, that's a 10, 1, so that's a 2, and that's 920.7776. 920, so that's 920.7776. And you need to add this, basically multiply 848 times 212 with 2 decimal places. So 2 times 8 is equal to 16, 1, 4, 8, 9, 16, 17, 0, 848. 2 times is equal to 16, 1, 2 times is equal to 4 is equal to 8, 9, 16. You have 6, 17, 1, and that's an 18, 1. So that's a 19, 1, 7, and 1. And you have 2 decimal places, that's 17, 98, And that's the problem here. I don't understand why I get a negative number here. Over here I have 4.24 squared. X sub I squared plus 4.24 squared minus 2 times x sub I times 4 to 4.24. Now I'm not supposed to get a negative number here. I don't know if I did this right. Sigma x sub I squared. Sigma x sub I squared is 902. Sigma x sub I 8.48 times 200. Sigma x sub I 212. Now let me do this calculation with the calculator. Let's see what we get. So 8.48 times 212 is equal to 1797.76, and 902.8 plus 4.24 squared equal to 920. And that's not supposed to be a negative number. Take a look at the solution. It's 4 x sub I squared minus 8.48 times x sub I plus 1797. There is something wrong here, that I have x sub I minus 4.24 whole squared, which is x sub I squared minus 8.48 times x sub I plus 4.17, okay, times 50. Okay, so it seems that I'm making a mistake here. Let me see. Okay, so I do need to start over here. Let me see. So I have here x sub I minus 4.24 squared, and basically sigma of that times 1 by 50. So then I have 1 by 50 times sigma of x sub I, okay? And then that's the same thing as x sub I squared minus 8.48 times x sub I plus 17.97. So let me rewrite this part over here and erase all of this. I'm going to just rewrite this part. Okay, so I have 4.24 squared. So we said that 4.24 squared is equal to 4.24 times, 4.24 times 4. I didn't want to write that. 4.24 and then 4 decimal places, so you'll get basically 4 times 4 is equal to 16, 1, 8, 9, 16, 0, 8, 4 and 8, 0, 0, 16, 1, 8, 9, and 16. So you get 6, 17, 1, and this is 12. 12 plus 5 is equal to 17, 1, and this is basically 10 plus 9 is equal to 19, 1, so 7, 1. 2 decimal places, I'm sorry, 4 decimal places, you get 17.9776. And now they have taken this value as 17.97, which is, well, okay. Well, I mean, technically it's not right, but because I want to just move on based on this solution, because I was making this mistake, and I did make the mistake the previous time as well. So I'm just going to take this value as 17.97, and this is, and then you have x of I squared, and then that's 8.48 times x of I, right? And and so I see. Oh, that's the mistake that I have been making, I suppose. Well, I did make a logical mistake here. And what that is that well, when you have, for example, sigma, let's say that you have sigma 1 as I goes from 1 to n. So then this is not changing. So then this is not changing. So what this means is that this is 1 plus 1 plus 1 plus 1 n times. Right? This is the mistake that I was making. So when you say, for example, sigma 1 as I goes from 1 to n, that means 1 plus 1 plus 1 plus 1 n times, which is equal to n. That is n times basically 1, which is equal to n. So the same thing applies here. So that was the problem that I had with the sigma notation, I suppose. So I can write this as 1 over 50 sigma of, that's why I said this was a bad problem, but a necessary bad problem. These problems, some of them are really necessary bad problems. So I have sigma x of I squared as I goes from 1 to 50. And then I have sigma 17 times 97 as I goes from 1 to 50. And minus basically, and then I can write this as 8.48 times sigma of x of I as I goes from 1 to 50. And 1 over 50 is multiplied by this whole thing. Now I know that sigma x of I squared as I goes from 1 to 50 is equal to 902.8. So I can, over here I can write 902.8. But then over here, sigma of 17.97, it's the same thing as what we just discussed. For example, sigma 1 as I goes from 1 to n is equal to 1 plus 1 plus 1 plus all the way up to n times. Right? which is equal to 1 times n, which is equal to n. Now if I write sigma of 1 as I goes from 1 to, for example, 15, that is the same thing as 1 plus 1 plus 1 plus 1, and so on and so forth, 15 times, which is equal to 15 times 1, which is equal to 15. Now, by the same logic, if I write sigma of 17.97 as I goes from 1 to 15, that's the same thing as 17.97 plus 17.97 plus 17.97 plus all the so on and so forth. Let's make it 50, for example. Let's make this 50 times, for example. 50, and here I can write 50 times. And that's exactly this thing over here, which is the same thing as 50 times 17.97, which is whatever that is not important, but it has to be equal to this. So it's equal to 50 times 17.97, and that's why we got that negative value, because this number was not large enough to take care of that negative value. Basically, in the sum, that the number turned out to be a negative value. So you need to be careful about the sigma notation. Sometimes, well, it's tricky. Now, and then over here you have sigma x of I as I goes from 1 to 50, which is equal to 212, which is equal to, so I can write this as 8.48 times 212, and multiply this thing by 1 by 50, and that is going to be the value of variance for basically for x. So now I need to calculate these two and then add the whole thing together to get the answer, which is nothing but basically, for example, 1797 times 5, and the 0, you have 2 decimal points and 1 0, so one of them is cancelled out, you have 1 decimal point. So you get 5 times 7 is equal to 35, 3, 45, 48, 4, 35, 39, 3, and an 8. And 1 decimal point, you get 898.5. And over here you have 902.8 plus this minus, and over here you have 8.48 or 848 with 2 decimal points times 212, which is equal to 16,189, 16, 0, 848, 2 zeros, and then 16,1, 8, 9, and 16. So you have a 6, you have 17,1, and you have 12 plus 3 is 12 plus 5 is equal to 17. So you have a 1 here, and then you have a 17 and 2, 19 here, 7 and 1, 2 decimal places, that becomes 1797.76. You want to multiply this whole thing by 1/50. And so what you have here is basically these two numbers. Let's add these two numbers and then subtract this number. 902.8, 898.5. So that's 3, 1, 11, 1, 0, 1, 18. That's 1801.3 minus 1797.76. Okay, and then well, you can make this as 7, 10, 9, 11, 10, 12, and 10. So that's a 4, 5, 3, 0, 0, 0, 3.54. So that's the same thing as 1/50th times 3.54, which you can simply calculate as, well, the mistake was mine, and that's a bad mistake to make. You shouldn't make that mistake. I mean, some mistakes in calculation is okay, is allowed. Sometimes you're going too fast, sometimes you're tired or something like that. You make mistakes in calculation, that's understand. But that sort of mistake is a bad mistake. You shouldn't make that sort of mistake. So now if you have 3.54 divided by 50, so you have 0.0, and then 354 divided by 50 is equal to 7 times 50 is equal to 350, 4 remainder, 0, 0, 0, 0, 0, 8 times 5 is equal to 400, 0. That's the same thing as 0.0708. That is your variance. That is, so sigma squared is equal to 0.0708, which is your variance. Now you are looking for, of course you can leave it here as well, but no, but you have to find the standard deviation. So now sigma is equal to the square root of 0.0708, and we get to calculate this as well. Okay, so the square root of 0.0708, you can actually, I've never actually done anything like this before, where the number actually starts with a decimal point. I suppose, well, I could make it group over here, and of course 0 would be simply 0, right? And then this decimal point comes up here, and then you have with the first group, this group, you can work on this group, which is, for example, 2.2 is equal, 2 times 2 is equal to 4, and subtract from this, you'll get a 3, and then bring this 0.8 down. 2 plus 2 is equal to 4, 1 digit here, 1 digit here, and 47 times 7, 47 times 7 is equal to 280 plus 28, 308. That's 308. Which is, so 7 and 7 and 308, 0, it's a perfect square, 0.27. Now 0.27 raised to the second power is equal to 0.729. And if I take the square root of 0.0708, I get 0.266. Now they have made some mistake over here. I must have made some mistake, or I might have used the algorithm wrong, because I never actually had used the algorithm for this kind of thing. So maybe the algorithm may be different for this kind of thing. If you want to do this kind of thing with the algorithm, you might actually have to make some changes. The value is very close, but it has problems, meaning that on a calculator, so the square root of 0.0708 is equal to the square root of, okay, 0.266082639, and it keeps going. So Okay, so let me start over actually from with this. So I have 0.0708. I want to take the square root of this number. So as usual, I can group them this way, group the numbers this way, and this will give me 0 times 0, which seems logical, although sometimes you cannot rely on logic, because when you're using an algorithm, you have to follow the algorithm. It might have actually nothing to do with common sense or logic or anything like that. Then I put the decimal point here, and 0 plus 0 is equal to 0, and bring down this 0.7. Actually, you would have to subtract 0 from this. You would get a 0, and then bring down this 7. And then 0 plus 0 is equal to 0. So you have 1 digit here and 1 digit here. So for example, 2 times 2 is equal to 4, 3 remainder, and you get 08 here. So 2 plus 2 is equal to 4, 1 digit here, 1 digit here. Or maybe I made a mistake in calculation. So let me see, 46 times 6 is equal to 36, 3, 24, 27, and 47 times 7 is equal to 49, 4, 28, 32. So that doesn't actually, that's actually not possible. So I have to go with 6, and you will get a 276, right? And then again, if I put 2 zeros over here, so it's working, there is no problem there actually. If you go with this, you will get 8 minus 6 is equal to 2, and then 10 minus 7 is equal to 3, and 2 zeros here. 46 plus 6 is equal to 1252. So I have 52 over here, and 1 digit here, and 1 digit here. So now you're looking for, like, for example, 6 times 526 times 6 is equal to 36, 3, 12, 15, 1, 31. And if I go higher than that, the number will not be acceptable. So I have to go with 6 and 6 here, and then 3, 1, 5, 6, and then you will get some remainder, and again the same thing, and so on and so forth, which is exactly the value that we got from the calculator, 0.26608,269, and so on and so forth. So I take this as 0.27. So the standard deviation is 0.27. So that's basically the standard deviation related to x. So I call it sigma of x. Okay, so now the next thing that we need to calculate is sigma of y. Now basically for y, the weight, again, what you need to do is basically the formula that we used for sigma was, we started with variance, which is basically sigma squared is equal to 1 over n, this sigma of f of I times x of I minus x bar whole squared as I goes from 1 to n. And we agreed we agreed to not to use f of I, so I can write sigma squared is equal to 1 over n times sigma of basically x of I minus x bar whole squared as I goes from 1 to n. And since my variable is y in this case, I write this as sigma of y squared is equal to 1 over n sigma of y of I minus y bar whole squared as I goes from 1 to n. That's the formula that I'm going to use. Now I need to, so to calculate this, you know that sigma of y squared is equal to basically 1 over n. We said that if sigma f of y was equal to 50. This number over here, sigma f of y is equal to n is equal to 50. So I need to calculate basically 1 over 50 sigma of x y of y minus y bar. Now in the case of y, the y bar was 5.42. Was 5.42. 5.42 all squared as I goes from 1 to 50. That is how you can calculate the variance related to variable y. Okay, so now again we have the same story here. We have sigma of, you want to calculate sigma of y squared, and well, I can simplify this as, for example, 1 over 50 times sigma of I goes from 1 to, for example, 50 of, and then I can expand this, meaning that I can write this as, for example, y of I squared plus 5.42 squared minus, well, 2 times negative 2 times 5.42 times y of I, which is equal to 10 point, for example, 84 negative 10 point times y of I. So negative 10.84 times y of I. And that is equal to, so you can write this as, for example, 1 over 50 times basically sigma of y of I squared as I goes from 1 to 50 plus sigma of 5.42 squared as I goes from 1 to 50 minus and you can write this as 10.84 sigma of y of I as I goes from 1 to 50. And so to calculate this, you know that sigma of y of I squared as I goes from 1 to 50 is equal to 1457.6 is equal to 1457.6. And over here you have again, this is basically 5.42 into 50. I'm sorry, 5.42 raised to the second power times 50, because there is 50 terms over there. And over here you have sigma y of I as I goes from 1 to 50. Sigma y of I was equal to 261 minus 10 times 10.84 times 261, if I'm not mistaken. Over here 261. So and then you need to divide this whole thing by 50 or multiply it by 1 over 50. So now let's do the calculation. Okay, so now to calculate this, what you need to do is, well, I did try to do the calculation, but I did make some mistakes here. I don't want to make mistakes again, or even if I'm supposed to make mistakes, I want to know how I'm making mistakes, because that's really not nice. So 1 over 50 sigma y of I squared. Sigma y of I squared is equal to 1457.6. 1457.6. 1457.6. Over here I have 5.42 squared times 50, which is correct. And over here sigma y of I was equal to 261. 261 times 10.84. Now we need to calculate these things. So for example, 5.42 squared times 50 is equal to 5.42 times 5.42. I'm going to forget about decimal points and put 4 decimal points here. And 2 times 2 is equal to 4, 2 times 4 is equal to 8, 2 times 5 is equal to 10, 0, 4 times 2 is equal to 8, 4 times 4 is equal to 16, 1, 4 times 5 is equal to 20, 21, 0, 0, 5 times 2 is equal to 10, 1, 5 times 4 is equal to 20, 21, 2, and 5 times 1 is equal to 25, 27. So that's a 4, that's a 16, 1, and then you have a 7 there, then you have a 3 there, then you have a 9 there, and you have a 2 there. And 4 decimal places, that's 29, 3764. So 5.42 squared is equal to 5.42 squared is equal to 293764. And if I multiply this number by 50, so 293764 multiplied by 5, so I have a 0 over there, and I have 4 decimal places, so I get 3 decimal places. 5 times 4 is equal to 22, 32, 3. 5 times 7 is equal to 35, 38, 3. 5 times 3 is equal to 15, 18, 1. 5 times 9 is equal to 45, 46, 4. And 5 times 2 is equal to 10, 14. And 3 decimal places, that's 1468.82. So that means that 5.42 squared times 50 is equal to 1468.82, which is the correct answer. 1468.82. Now this number over here is 1457.6 plus this minus this number, and we need to calculate this number as well. So over here I have 10.48, 2 decimal places, times 261. Times 261. So I have 1048, 0. 6 times 8 is equal to 48, 4. 6 times 4 is equal to 24, plus 4 is equal to 28, 2. And 6 times 1 is equal to 6, plus 2 is equal to 8. So 6 times is equal to 48, 4. It's 24, 28. And 6 times 1 is equal to 6, plus 2 is equal to 8. Then you have 0, 0. 2 times 8 is equal to 16, 1. 2 times 4 is equal to 8, 9, 0, and 2. So then you have an 8 over here. You have 12 over here, and 1. 14 and 15, 1. And 4 plus 9 is equal to 13, 1. That's 1 plus 8 is equal to 9, and that's a 2, and 2 decimal places, I get 2935.28. So 10.48 times 261 is equal to 27, what? 2735. I think I made a mistake here. That's supposed to be a 6, of course. And then 6 plus 1 is equal to 7. So 2735.28. So that's 2735.28. And so now if I add these two numbers together, I'll get 1457.6 and 1468.0. And so I have a 2 over here, I have a 14 over here, 1, 15, 16, 1, and then I have basically 6 plus 6 is equal to 12, 1, and I have 4 plus 4 is equal to 8, 9, and I have a 2 over there and the decimal point. And subtract from that 2737.28. So you'll get a 3, 12, 12 minus 8 is equal to 4, that's a 1, that's a 1, and you have a 8 and 12, so 12 minus 3 is equal to 9, 1 and 0. 191 times 0.14. So that's the same thing as 1 over 50 times 191.14. And let me add these numbers together quickly. 1457.6 plus 1468.82 minus 2735.28 is equal to 191.14 divided by 50 you will get 191.14 divided by 50, you will get basically 3 times 50 is equal to 150. You have a 1, you have a 4, and you have a 1 over here. 8 times 5 is equal to 400, remainder 11, and then you have a 4 over here. 2 times 50 is equal to 100, 14 remainder, 0, 0. 2 times 50 is equal to 100, again 40 remainder, and 8 times, so that's 3.8228. That's equal to 3.8228. So 191.14 divided by 50 is equal to 3.8228. So that is your sigma y squared. That is your sigma y squared. So that means that sigma of y squared is equal to 3.8228. 3.8228. That means that sigma of y is equal to the square root of 3.8228, which is the same thing as, well, 3.8228. If I want to take the square root of that, you will get 1 times 1 is equal to 1, remainder 2, decimal point 82, and you will have basically 28 times 8 is equal to 160, 29 times 9 is equal to 81. 18 plus 8 is equal to 18 plus 8 is equal to 1626. Okay, 261. So you have 9 over here and 9 over here. 9 times 29 is equal to 261. 2 minus 1 is equal to 1. 8 minus 6 is equal to 2. And then 28, you can bring it down. Next you have to add 9 to 29. So 29 plus 9 is equal to 18. 1. So that's a 38. 38 here and another digit here. So then you have basically, for example, 3, that's around 3, and that's around 400. So 5 times 400 is something around 2000. So 385 times 5 is equal to 5 times 6 is equal to 25. 5 times equal to 40, 42, 4. 5 times 6 is equal to 15, and 19, 1925. So you get a 5 over here, a 5 over here, and you have 1925. And you will get some remainder over here. So, and let's just continue one more step. Let's continue one more step. So you have a 3 over here, a 0, and 203. I put 2 zeros over here. So 385 plus 5 is equal to 390, and 1 digit here, 1 digit here. So this is around 4,000 if I put a 1 over here, and this is 20,000. So 20,000 divided by 4,000 is equal to, well, around 5 times. So 395 times 5 is equal to 25, 2, 45, 47, 4, and 15, 19. Right? Oh, sorry, 390 and a 5 there. So, so I would get 5 times 5. So I'll do this again. So you have 5 times 5 is equal to 25, 5 times 9 is equal to 45, 4, 5 times 3 is equal to 15, 19, 19,525. 525, and you get 5 here. So the square root of this is going to be, I'm going to take this as basically 1.96, for example. 1.96. And so that is your sigma of y. So as you can see, now what I need to do is calculate the coefficient of variation of these two distributions. So sigma of y is equal to 1.96. So we calculated x bar as 4.24, y bar as 5.42. We calculated sigma of y as 1.96, as 1.96. We calculated sigma of x as 0.27, which is a little bit odd. 0.27, and now let's calculate the coefficient of variation. Let's calculate the coefficient of variation. Okay, so now the coefficient of variation, basically the coefficient of variation for x, basically you know that coefficient of variation is equal to sigma, that's not sigma, is equal to sigma divided by x bar times 100 times 100. So that's equal to sigma of x is equal to 0.27 times a times 100 divided by x bar. X bar is equal to 4.24. 4.24. That's the same thing as 27 divided by 4.24, which is the same thing as 2700 divided by 424. Now 2700 divided by 4.24 is equal to 5 times 400 is 2000. 5 times 20 is 100, is equal to 100, and 5 times 4 is equal to 20. So you have a 0, you have a 2, you have a 1, and you have a 2. That's 5 times 424. Now 424 times 6 is equal to 6. 6 times 4 is equal to 24. 2. 6 times 2 is equal to 12. 14. 1. And 6 times 4, 24. 25. 25. 44. Okay. 424 times 5 is equal to 2120. 424 times 6 is equal to 2544. I think that's the value that you can use. So 62544, and if you subtract, you will get basically a 6 here, a 9, a 10. That's 10 minus 4 is equal to 6. 9 minus 4 is equal to 5. 1, and that's a 0. The 0 over here, a decimal point. And then you have, I think, 4 times 424 times 4 is equal to 16. 1, 8, 9, and 16. Not 4 times. So 424 times 3 is equal to 12. 1, 6, 7, 12, 1272. So 3 times would be 1272. And 10 minus, let's make this a 4, make this a 15, and then make this a 10. That's 8, 8, 2. And make this a 0. And go for 7 times. Let's see what happens. 7 times would be around 2,900 something. So which doesn't fit here. So you have to go with 6 times. So 2,544, and you will get some remainder here. I'm going to take this as 6.4. 6.4. That's the coefficient of variation for x. Now, the coefficient of variation for y, you have again the coefficient of variation is equal to sigma divided by x bar times 100. So sigma of y was equal to 1.96. 1.96 times 100 divided by x divided by y bar, which was equal to 5.42. 5.42. So it's equal to where y bar was equal to 5.42. So that's the same thing as 196 divided by 5.42. which is the same thing as 19600 divided by 542. And to calculate that, 19600 divided by 542 is equal to, basically, that's around 2500. So 4 times what? But 4 times doesn't really fit. 542 times 4 is equal to 816.1, and that's 2021. That's 21. So that doesn't fit. So 542 times 3 is equal to 6, 12, 1, 15, 16. So we go for 3 times 16, 26. 16, 26. So you have a 5 here, a 10 here, a 4, a 3, and a 3 is 0. So you have 500, and that's 3000. So that's around 6 times. So 542 times 6 is equal to 12, 1, 24, 25, 2, and 30, 32. So 6 times would be 3252. Now, make this a 2, a 13, and a 10. So that's an 8. And that's an 8. And then you have 13, 5 plus 8 is 13 minus 1 is equal to 8, and 0, 0. Then decimal point 0 and decimal point. That's 1 times 542 is 542. Remainder, make this a 7, make this a 10. That's an 8. That's a 3. That's a 3. Another 0 here. 3380. So 6 times, I suppose that would be 3252. And make this a 7, make this a 10. That's an 8, that's a 2, that's a 1. And so I'll take this as 36.2. Take this as 36.2. And of course you can see that the length was more or the weight, you can see the weight was more varying, basically more variable. Let's take a look at the answer here. The weight was more varying, and let me take a look at the values that they have gotten here. 1.37, 26.24. The values don't seem to be probably right. Standard deviation was 0.26. The standard deviations of length was 0.26. .13. So this seems to be right. This seems to be in accordance with the value that we have gotten in the book. I'm sorry, in the solution. Now for the variable y, we have the coefficient of variation is something about 26. Let me do this calculation here. Let's see what I get. 1.96 times 100 divided by 5.42 is equal to 36. Well, maybe we have made a mistake somewhere, but that's okay. I mean, I have done my best to not make mistakes. I have made mistakes. I have gone back and rectified everything and corrected the mistakes. But basically that's, well, if you take the process over here as well, that's even more than enough. So you don't need to worry about the mistakes. It seems that basically the coefficient of variation for y, the correct value for this is basically for y, the correct value is 26.24. Okay, so that's basically the whole thing here. Now I'm going to end this video here, and then in the next video we will talk about the miscellaneous examples. I'll see you in the next video.